presentation about how Knewton manages their environments. So I don't really have a whole lot to say. I think it's a pretty interesting problem. I have to deal with this, like multiple AWS accounts, and like, I don't know, I think I deal with like a dozen different environments because staging and testing and production and next and all of those aren't enough. So maybe you guys share that same pain, and I think Chellick will be able to kind of show us the light, or at least give us some ideas, and also allow us to talk about how everyone's kind of solving these problems and get ideas from each other. Before Chellick starts though, I wanted to let Tim Apno from Ansible-NYC give a quick 1-minute chat about Ansible Fest Brooklyn. If you guys haven't gotten your tickets yet, totally recommend it. Tim will give you the details, but he's got a special code so you can get a discount. So yeah, Tim.
Woo. Exactly. So it's more of an announcement than a talk.
Yeah.
Hi everyone. I'm like Dan said, Tim Apno from Ansible. So I just wanted to make sure everyone knew that Ansible Fest Brooklyn is coming to town, just right across the river in the Marriott there by J Street Metro Tech. It's October 11th. And if you want to go, right now we're in early bird pricing, and you can use this promo code COWSAY, C-O-W-S-A-Y, and I'll give you an additional 30% off the tickets. Call for speakers is still open for another few more days, so if you have a talk in mind, talk to Dan and Connie, because they're always looking for speakers, but also we're still collecting for speakers for that event. And there's also a contributor. Is anyone here a contributor to Ansible? Like they've made code contributions, or they deal with folks like Brian Coca? All right, well, there's a contributor conference the day before that our core team and a lot of our community team will be meeting and talking a lot about the future of Ansible, if anyone's interested in that. So that was it. Just wanted to make everyone aware of that. Remember CalSay. There's a limited number of those, so you got the 30 of you use that, it's gone, but it's out there for you. So thank you for all coming out and supporting us. Hope to see you there.
Thanks, Tim. All right, and all right. So now Chellick. So just as so Chellick would prefer if any questions, kind of wait, save them for the end. You know, probably if it's super quick, maybe we can answer it. But if it's especially something we want to discuss, let's try to save it for afterwards. We'll have about half an hour, 45 minutes to kind of mingle and chat and ask questions. So, all right, thanks guys, and enjoy the presentation. Thanks, Chellick.
So, thank you. Hey everyone. Woo. First I want to start by thanking everyone for coming out tonight. It's a beautiful Wednesday, so I really appreciate it. So I'm going to start talking about how Newton manages environments with Ansible. Before we start, I'll do a quick bio, a little bit about myself, and what Newton does. So Knewton is a late-stage startup. We specialize in adaptive learning. I've been working at Newton now for about 2 years as a systems engineer. Currently working as an observability engineer, which is underneath our systems engineering branch. So basically what I want everyone to leave with tonight is an understanding of how we manage environments with Ansible. So let's do a quick background about our infrastructure. So these are the simple days. When we came in and we had a single billing account with an environment that lives within a VPC. We have some support infrastructure here, and then we have our 2 services here. Before I dive in, how many people are running in the cloud? Right. And then on bare metal? So for those in the cloud, are we large AWS or other providers? Cool. So these are the simple days. We have one environment, we've got our core infrastructure here, and then we've got our services. Things are great. Someone comes along. Hey, Chellick, I want to do some load tests, but I don't want to affect this environment. Would you mind spinning me up an environment so I can run some load tests? Sure, why not? We want to test our code, I want to help out. So we start spinning up another environment. So here we are, single billing account, new VPC, some more core infrastructure, and then we have the same services we have here, but they're interacting differently. Another person, hey, Chellick, I've got more tests. Would you mind spinning up another environment? Sure, why not? I want to help. So here we go again, another VPC, more core infrastructure, and then we've got 2 services, different tests, different interactions, same basic setup. This is when things started to get complicated. At this point, someone comes over and says, hey, Charlie, I'm not seeing metrics in my environment. You mind taking a look? Sure, why not? I want to help. Hey, Charlie, by the way, I'm not seeing any logs in this environment. You want to take a look? So one thing we started to notice is that as we built these environments out for people, that as we were scaling the core infrastructure linearly, but the team size wasn't changing. So every time someone wanted a new environment, we had to rebuild all this core infrastructure, and we also had to maintain it. Not fun. Does anyone have the same problem? All right, well, there's got to be people out here with that. So this was an idea. We were like, how can we change this to be more, adaptive and help our team, go to bed at a reasonable hour? And we noticed that, hey, look, a lot of this core infrastructure is all the same. It doesn't make sense that every time we spin up a new environment, I've got to spin up a new metrics backend, or I've got to spin up a new log processing engine, or we've got to re-add these databases. It's just a lot of infrastructure to maintain for what? Only 2 services that are having different interactions. So this is where the idea of logical environments began. So what is a logical environment? So basically what we did was we said, hey, look, inside our VPC here, we can have 2 logical environments, and what they'll do is instead of having to spin up this core infrastructure for every environment, what we can do is we can have these logical environments share these resources. So this gave us a handful of advantages. A few of the benefits were it's cheaper. I'm not spinning up hardware every time I spin up a new environment. It was easier for us to set up because there's just less infrastructure for us to spin up. And then in terms of the shared infrastructure, if we needed to scale them, we would scale those horizontally. So that's one of the deciding factors in what can we share and what can't we share. Also, less operational complexity, like I hinted at earlier. Every time we spin up a new environment, we had to manage we had to manage a stable infrastructure across every environment. So less infrastructure to maintain means less infrastructure to maintain, right? And then lastly, it's just simple. So for services that we're using a shared resource, in order to determine their logical environment, we use namespacing. But with these changes, life isn't simple. So we did have some costs. As you probably can notice from the slide, is that these services are all sharing this core infrastructure. So one question is, what if services in this environment start hammering services in the shared environment, right? Well, that's what happens is the environments that are also sharing these resources are also affected. So there is no isolation when it comes to these shared resources. It's kind of hard to limit permissions, we notice, because some of our shared resources, the permission sets are on the IAM level. So we can't specify a shared resource has access, the environments have access to certain resources. The tools became more complicated. You couldn't just infer the logical environment name from its physical environment. And they're not all the same. Each logical environment was different. There wasn't the same service in each one. So if something broke in one logical environment, it wasn't the same process to fix it in another. But we really like this approach, so we started using it more. Hey, Chell, spin me up a logical environment so I can test my service. Boom, spun one up. Hey, Chell, wait, you can do this yourself, guys. Spin yourself up another logical environment. So that's what we started noticing, is that the systems team didn't really have to be involved when these new environments were created, that service owners could actually do it on their own. So we started building logical environments and sharing the same resources. This is great for us. If I have to debug an issue, it's on one set of shared resources, not in every environment. So we started really using it. Also, we have logical environments across building accounts. So we're spinning up environments. We're loving this. Things are flying, we're growing, right? Things are rolling. We're happy there. More problems now. So with this, we noticed a few growing things. People started wondering which environment is in which building account, right? Ansible needs to know where your resources live. We have to make API calls to AWS somehow, so we need to know which building account. How do I configure my AWS keys? Now that we have different accounts, you've got to configure more keys. Do my keys have the right permissions, right? Users need to be able to do things, Ansible needs to be able to do things when it's making calls, so we need permissions. And then we ran into an issue with, how do I set a variable for just one logical environment? So basically what we wanted was something to be simple. we need something to be secure, and we needed an Ansible to be environment aware. This caused us to create two requirements. One, Ansible should understand environments. That was huge for us. And the second is Ansible should manage its own permissions. Do you guys have any issues with your Ansible setup currently where people have issues with keys or making API calls? Do you see that happen often? All right, cool. So I'm just making sure we're not the only people with this problem. So let's start. So Ansible should understand environments. So we use ec2.py. It's a dynamic inventory. It's open source. Ansible gives it to you out of the box. A few cool things that it really does is that it can group your infrastructure by security groups, AZs, regions, tags, instance ID. There's a couple I'm sure I didn't add in this slide, but these are a few of the important ones. And we especially like this idea of grouping our infrastructure by tags. So that's what we did. We started tagging all our AWS resources. Tags. So we started tagging our physical environment. So I'm not sure if you guys can read it. Can you guys read in the back?
It's a little small, but.
A little small? All right, cool. So I'll underline and I'll read it out here. So we first started by tagging our VPC. We gave it a name, an environment. You can see that we have two services here. They've got their name. They also have a logical environment tag. This is important because what we saw back here with ec2py is we can group hosts by tags. And then also for help we have which VPC this lives in. And you can see here we also tag our shared resources also. But what you notice different about our shared resource is they are part of the default logical environment. And essentially what the default logical environment for us is the shared resource environment. So awesome. Now we can start grouping our hosts. So we have our logical env tag, and we've got a group now. We've got a group of hosts that live in one environment and a group of hosts that live in another environment. Excellent. Still have an issue though. How do we set a variable for just one logical environment, right? Because which inventory does ec2py generate? So the question is, how does, out of the box, ec2py generates inventories based on, does anyone know? Billing accounts. So when you trigger your ec2.py, you generate your inventory, it's going to generate you an inventory for the specific billing account that you specify. So our inventory would look like this. This isn't exactly what we want, right? We think in terms of environments, not in terms of AWS billing accounts. Not good. What we want is something that looks a little like this, right? So this is more like the inventory we want. We have our logical environment with its shared resources, as well as a separate logical environment with its shared resources. So this is where NewtonConfig came in. So NewtonConfig is a Python package that has an environment module in it. Basically, what the environment module does for us is what users can do is specify their target environment, and they'll send that environment into NewtonConfig. And what NewtonConfig does is it returns metadata about that environment. The metadata looks similar to this, the full name of the environment, the logical environment, and then the region, and also which billing account this environment lives in. So what we do with that then is we take this logical environment feature and we use Boto filtering to generate inventories for this logical environment plus the default logical environment. So by filtering by those parameters, we generate inventories now based on logical environments, not billing accounts. So another question is, well, how does Ansible get permissions to make these API calls, right? Because you saw on this slide, back in early days, we were passing a profile. So we're saying, users are saying, hey, look, I want to target this environment for my Ansible run. I'm going to run this playbook, and I need to know which environment. This is the environment, like the billing account that this environment lives in. So we need to know how can Ansible manage its own permissions. So back to this slide. So which inventory does ec2py generate? So it generates them based on billing accounts out of the box. How? by either passing in a profile, like we see here, or exporting your account keys. So this is where this issue came in. Which environment is in which billing account, right? This becomes complicated. And this is kind of complicated for users as well. So how can we know which profile our environment lives in? We have this metadata. What this metadata does is it has the billing account this environment lives in, as well as the region, which are the two requirements for Boto to make an API call. Hallelujah. But how does it get its keys? So here at Knewton, we have a service called Vault. What Vault basically does is it manages any type of secret data. So this can be API keys, any type of keys. And one key advantage is that it has dynamic secrets. And what I mean by dynamic secrets is most people, I'm sure, the way you guys do it is that, well, actually, let's do a quick survey here. So when you run Ansible, you guys have just one Ansible key for the entire team? Any hands? Oh man. All right, how about each user has their own key? How do you guys access AWS without keys? I mean, without AWS keys? Well, so that's typically how I see it in most places. Is each user has their own access keys, and in a Boto credentials file, or you can export your keys. Well, with Vault, we can do dynamic secrets, which means Vault can actually generate us keys that are only for that execution. And every key, every client that reads from Vault has a mandatory lease contract, meaning that the keys that Vault provides you expires. So now we've gone from the model of, here, I'm going to give you some keys, these keys work forever, when you get fired, we'll delete your keys, to that after this execution, those keys are no longer valid. So every time you run Ansible and have to make a request to Boto, we generate new keys. And this has a lot of advantages, one being auditability, another being limit the blast rates if the keys are exposed, and the fact that after an execution, the keys are no longer valid. So if the keys are just sitting on someone's laptop, or someone uploads them to GitHub, you can't do much with them. So we said, hey, we got this Vault service. Let's create a custom client just to talk to Vault. That's what we need. So we took Vault, this is our logo, and we created something called KVault. Here at Knewton, we like to put the letter K in front of everything, just as it's coming from Knewton. So we have KVault. So how does KVault work? So we know that it's going to take this metadata and make a request to Vault. So when the client makes a request to Vault, it says, hey, look, I need permissions for this billing account, and I need this type of permissions, right? So the permissions are handled via Ansible. Users don't create their own keys and set their own permissions now. We say Ansible needs these permissions to do its job. And Vault sends back keys that are written to the Boto credentials file, and then when Ansible reads from that file to make a request to Boto to generate these inventory files, it has the keys it needs. So let's talk a little bit about how we got to where we are. One of the things we wanted to answer was Ansible should understand what environments work for Knewton. And so our solution was, hey, let's use tags to group these logical environments together. But we still have the issue of, hey, how do I define variables for just logical environments and not entire billing accounts? So users also targeted their environments by passing in that Ansible end we saw back here. So now users, when we run Ansible, just define the environment they're targeting. There is no use for the profile. That profile is no longer needed because we get metadata from our NewtonConfig. Next, we have NewtonConfig, which essentially just generates metadata about the environment and tells Ansible, hey, the environment you're looking for is in this billing account, in this region. Its full name is this. Its logical environment is this. So now Ansible knows about environments. That's great. So we have our inventories based on environments. Next, we need to know, hey, now that we know about environments, how do we make calls to AWS? Where do we get the keys and permissions? So we had Vault already installed, running, but we weren't using it. So we need to create a custom library that was able to talk to Vault and fetch keys for Ansible executions. So with that, then we were able to, now we can talk to AWS without having to worry about keys anymore. So if for some reason I left my laptop open and someone took my keys, I'm not going to be that concerned anymore. And also from a usability standpoint, users no longer had to fuss with which profile it is in, how do I get keys, can you make me keys? Because I'm sure plenty of you have got requests for, hey, I need access to this environment, can you make me keys? We decided to automate that process. And in the process of automating it, we were able to add a lot of awesome security features. So I'm sure you guys are curious, like, hey, this is awesome. You guys do some cool stuff. How do we do it? So I put together a couple links that might be useful. We have, this is a link to the Vault project. This is a link to dynamic inventories. I'm not sure if you guys all use them. How many of you use dynamic inventories right now? All right, so quite a bit. And then how many use static inventories? Cool. And then one good thing for us is that Vault has gone ahead and they've written a blog about pretty much what we're doing, minus the custom client. That's really all I got, so I'm sure you guys have questions, and let's go ahead and start answering some. Yeah?
I mean, you probably can't share the source code, but just kind of an overview of what your table module does, like the structure of it, what it kind of calls and makes either via API to Vault or API to the
Yeah, yeah, let me go back to the slide up for some visualization. So basically what is happening is when we invoke ec2.py, we first make this call to the NewtonConfig to get this metadata back. So now we have this environment object. And so we say, hey, we need, so there's got to be some communication between ec2.py and Vault. So we have this custom library called cable. So basically what we do is we pass in an environment object, and that object has some information about which billing account, which region it lives in, and from there, it says, hey Vault, give me keys to this billing account. And Vault says, okay, cool, I'm going to generate you a user, and here's an expiration date on this key. It sends back those keys. Those keys then get written to the AWS Moto credentials file in a specific profile, right? Because EC2 out of the box, we said earlier, knows things about billing, AWS billing accounts, but not environments.
So is this typically run from like Apache nodes, your desktop, Jenkins, Travis, like what's your?
That's a good question. So the question was, do we run this in some form of automation, or is it run from users' laptops? So the answer is both. Right now, I think we're seeing it being ran more locally than we are from our automation processes because we're continually developing our infrastructure. So we run Ansible quite a bit locally. There's a flag that checks if we're on an instance or if we're not. And if we are on an instance, it'll use the role of the instance as opposed to requesting a set of keys.
Cool.
Does that help answer the question? Yeah.
Can you say what you mean by running on an instance?
Yeah, my bad. So what I mean by running on instance is that we're running Ansible via a server in AWS's infrastructure. So at a high, basically AWS has their term for servers is instances. And so Ansible, you can run it either locally on someone's laptop where we're running these command lines, or you can automate it to where Ansible is being run by a service on AWS. Yeah.
How much cost savings did you realize when you did it?
Oh, from virtual environments. That's a good question. So at a high level, you start to notice things like, let's see here. This is the slide I'm looking for. I want one. Here we go. So, you know, before in our old environment, we would have these 5 hypothetical services running in every single environment. In terms of dollar amounts, you can think of it like this, is that every time we built a new environment, we scale our core infrastructure costs linearly. So every time a new environment was built on our old infrastructure, we had to have these same core services. And not only did we have the cost of the core service, but we had the cost of us having to maintain it. So sometimes you get lucky and you're like, hey, my one metrics backend is working perfectly. I don't have to worry about it. But it's hard to be lucky like for 15 or 20 environments. And at some point, your luck starts to run out and you're debugging multiple metrics backends, sometimes even looking at the same issue. That's a good question, though. Thank you. Yeah.
How do you keep track of your logical environments? Like what internet or how's that sort of track?
Yeah. So the question was, how do we track our logical environments? So there's a couple ways we do this. We have to update our ec2.ini file every time we add a new environment. Also, this NewtonConfig file. So to be honest, this NewtonConfig file is quite simple. Really, what it does is it has these values for each environment hard-coded. So every time we add a new logical environment, we have to update NewtonConfig to have the metadata for that logical environment. Does that answer the question?
Yeah. So, like, what are your kind of like next steps?
Yeah. So there is a couple issues with this, and one big one is that if we want to make an update to all of our infrastructure at once, we can't exactly do that. So we have to run this multiple times to update multiple billing accounts, because now our inventories think of things as environments. So technically, for one billing account, we could have multiple inventory files. So I think we would like to come up with a better method for mass updates across our entire infrastructure. That's what I can think of off the top of my head. Any other questions? Yeah.
Do you have any plans to put this as like on the main module?
What was the question?
Do you have any plans to like merge the stacks like a main module?
Oh, gotcha. So the question was, do we have any plans to merge our changes back into the main ec2.branch? I mean ec2.py branch. So one thing is we've really customized this to be very Newton specific. But if we hear some rumblings from the community, I think we would be open to trying to open source something like this. Anybody else? Yeah.
What's the benefit to logical environments or just having a bunch of physical environments?
So the question was, what's the benefit of having a bunch of logical environments as opposed to having multiple physical environments?
Yeah.
Well, one big advantage is the fact that we can share all these resources. So instead of having a bunch of physical environments that have the service and the supporting infrastructure, we have a ton of small logical environments, and we share this core infrastructure. And as well as that, service owners can spin these up easily so they can run tests, load tests, back to school tests. It's a good way for us to ensure code quality on top of a bunch of other things.
So it's like an isolation.
Exactly.
It's a library. It's almost like containers for environments.
Right.
Within the shared infrastructure there, are those being isolated?
Yeah, so by default, anything that isn't in a logical environment, like defined to be in a specific environment, it gets pushed into our default logical environment. Yeah.
Our friend here said it's like containers, so why not containers?
We do manage containers. So containers is one of our shared resources in this hierarchy. I didn't want to clutter the slides with tons of extra stuff. The key thing to really take away is that with this model, we don't have to replicate all the same services just to manage a few services that are being tested. Yeah.
So if service owners are like spinning up their own logical environments, are they updating the INI so that you're aware of this when you need to run your Ansible against it, or like how do you guys know when like what logical environments are actually available to run your config management against?
That's a good question. So the question is, how do we manage logical environments when service owners can spin up their own? So one thing I didn't mention, which I probably should have when I started, is that at Newton, anybody who's a developer can and does use Ansible. We don't have a specific Ansible team. We have a team that tries to keep it clean, which is our systems team, but any user who's a developer at Newton can and does run Ansible. And yes, you're right, they do update all the files that are necessary to have new logical environments. Yeah.
is one of the logical environments that shares the shared resources, the production in logical environment? Or is
It could be.
production entirely separate?
It could be. So in production, we have multiple logical environments that share core production resources.
But do you have environments that are both production and development simultaneously?
Oh, good question. So the question was, do we have environments that are both production and non-production environments sharing the same pool of resources? And we do not. And I think that is really hits on one of the costs with it is that, where is my cost slide? Is that no isolation, right? So we don't want to run the risk of having some environment in QA or in a lower environment breaking a shared resource that production is using.
How often do you tear down environments or logical environments?
That's a good question. I'd say not as frequently as you would think. We have a bad habit of keeping logical environments up longer than we should. I'm not exactly sure on the time frame though.
So you isolate environments to these logical environments. What's the method that you use to actually make things limited to one logical environment? Like if I have EC2 instances or an RDS database, how do I put them in one logical environment?
So the question is, how do I put instances in a single logical environment? So when we have our, we have playbooks, so we have, the way our structure is, we have like a playbook that creates infrastructure and then a playbook that provisions infrastructure, right? So provision meaning like create the resources, meaning, so one brings up the hardware and the other adds all the software components we need. So when we run our create playbook, which is creating the underlying hardware pieces, we specify which logical environment that these resources need to live. And you can see that here a user to this by specifying in the command line their target environment. So we'll say, hey, look, we want to spin up an EC2 instance in a QA environment, and then we specify the playbook, which would, for us would be a playbook that does creation.
Any other questions? Or does anybody want to talk about how they kind of solve this problem? So I work at HBO. We have multiple accounts. And we also use EC2 PY, but we're not as clever, and so we actually just hack the EC2 PY script so that we can just pass in specific environment variables that it kind of expects as variables at runtime, and then we just have Jenkins set environment variables before it. But then we still have to mess around with the IAM role so that Jenkins can talk to like one of our 5 different accounts and all of that kind of stuff. And I suppose the one thing that we do a little bit differently is that we expect that the inventory script will only return the appropriate systems, and so in our playbooks we just say run all, right? Like we do everything in a playbook because we're really crossing our fingers that we only get back. And of course we have other checks in our playbooks to make sure we don't accidentally go and install Cassandra on our Oracle node or something like that, but that's kind of like maybe our Achilles heel to this whole problem, right? Or would be our Achilles heel. Like anybody else have similar type of solution?
So,
What's your name, by the way?
Chris.
Chris?
So for separating out applications or services rather, we're running Kubernetes, and we use each namespace to separate that out. Within our databases, actually use something similar to this to keep both like create a new user, new database itself. For the same physical database, just different creations using just another environment variable that breaks out of staging, production, SQA.
Do you typically run your Ansible jobs out of like a CI/CD deployment, or is it all usually like at your desktop?
So the way we usually have it is we have our cloud init files pull off our Ansible playbooks off of our object store, and then we run one initially at boot time, and then with when we do need to actually update the machines, we will actually kill the old ones and then just spin up new ones. And
Yeah,
of
so
course,
kind of like an immutable or blue-green kind of deployment. Cool. Awesome. Thanks for sharing, Chris. Anybody else want to talk about how they've solved a similar problem? Like, I still have problems with the multiple accounts, even just like I'm trying to test something from my own desktop, and you know, our backend services account is one profile, and our front-end services are another profile, and I've certainly been known to like get those confused and maybe deploy the wrong system to the wrong account, but in the end, it's like not the end of the world. Does anybody else like overcome that challenge? I think the vaulting is something I'm going to go back and take a look at tomorrow with our infrastructure team about how we can maybe deploy something like that. So.
Yeah, that's a lot of simplicity with the process because you don't have to think about keys, and users don't have to bug you about getting the right keys. If someone is, if we hire, like when people are hired, we don't have to sit down and give everyone the certain permissions.
Right.
Ansible, no. So if you think about Ansible like an application, it handles its own access. So it says like, hey, for me to do things in AWS, these are the permissions I need, and it gets the keys, not the user.
Is anybody using like something other than AWS, like Google Compute or Rackspace, where the challenges might be a little bit different, whether it's inventory or account access?
pretty similar to Google.
Pretty similar to Google. Any Rackspace or OpenStack? OpenStack kind of has a similar thing to AWS, like IAM roles and keys and stuff like that. So some of the solutions might be similar. Anybody else have any other questions for Chelik? I think it was a great presentation. Really appreciate you taking the time to.
There was a question over there.
Oh, was there?
Yes. He was about to. Oh, he was about to clap.
So anyway, thank you. I think one for clearly explaining the problem that a lot of people have and maybe have trouble kind of just like talking about, and then also for kind of giving us an overview of a way out of it. So really appreciate it. Thank you again. All right, so if you guys want to sit around, we've got like, you know, we can half hour, 45 minutes to chat. We're kind of out of pizza. There's a couple of beers left maybe and some soda. So nobody's getting wasted, but help us up.